and then let everyone in. Good morning, everyone. Welcome, welcome. Just gonna let everyone in before we start. Have it. All right. Well, welcome everyone to day 8 of the New York Craft Brewers Conference presented by DWS. My name is Jen Myers and I'll be the moderator for this session. Welcome to Refrigeration and Maintenance presented by John Mayer from Arctic Refrigeration and Eli Fish Brewing. Hi, John, how are you doing?
Good, how are you?
Good. Before we begin, just a couple things I'd like to touch upon. First, I'd like to thank our Wednesday presenting sponsor, TLF Graphics, and our Wednesday session sponsors, Breeze Malt and Ingredients, Link to Hospitality Solutions, Ultimate Brew Service. Thank you so much to our allied members. It is possible we're doing this because of you all, so thank you again. I'm also going to put a bunch of links in chat. If you wouldn't mind, please sign our attendee sessions sheet. We're trying to keep track of how many people are attending each session. Thank you. Without further ado, I'm going to introduce you again to John Mayer. John, go ahead.
Well, thanks everybody for coming. I'm John Major. I am one of the owners here at Arctic Refrigeration. My grandfather started the company 1947. He started working on grocery stores and farms and milking parlors, that type of thing. And we got into wineries. We do full service mechanical. So we do, heating, air conditioning, steam boilers, refrigeration, you name it, we do it. But we focus on refrigeration, commercial refrigeration. I am also one of the owners and brewers for Eli Fish Brewing in Batavia. So you put the two together, and I like to think I have a unique skill set that maybe I can help you guys out. One of the reasons that I asked Paul and everybody at the Brewers Association to let me speak today was basically we've been an allied for a few years. Obviously, I'm a member on the brewer side. And we saw a lot of presentations on law and tax and accounting and OSHA and that type of thing, which is great. We all need it, but there wasn't a whole lot on the technical side. So refrigeration is one of those things that kind of looms in the background. Everybody kind of has a little bit of grasp on it, but they don't know, at least in my experience, how to keep it going, how to maybe talk to your technicians about it and be a little bit more knowledgeable. So that's where I'm going to go today. Real elementary. I'm not going to get into the inner workings of refrigeration systems. I mean, people go to college for that stuff. It's not going to get covered today, but we're going to talk about what it is, what it does, how to keep it clean, and maybe learn a little bit in the process. If you guys have any questions, hit Jen up. Jen's going to notify me. I can't see you guys, so I'll do my best to answer any questions. If it's really technical, I might have to get back to you on it. But let's dive in, see what we can do. Okay. Like I said, my grandfather started the company in 1947. That is their very first service truck there, and we are all the way up to 16 employees now. We service all of New York. We just got done with a few jobs down in the Hudson Valley. We are also servicing agricultural clients in 9 other states. So we do get around. We're very specialized in what we do. If you guys need help in any area, basically the Northeast, we can generally help you out. So I did touch on this. What we're going to do today is very, very quick crash course on refrigeration and maintenance. We're going to touch on the refrigeration cycle. What is it? How does it work? Discuss the different types of refrigeration. Basically, going to touch on what's in the brewery. There's no point in getting into some of this more exotic stuff. We'll highlight it a little bit, but we'll talk about what's in the brewery. Discuss proper sizing and application. This is a big thing with breweries. We're always trying to save money. So used refrigeration, we'll talk about that quite a bit. And then finally, we'll wrap up with basically, I refer to it as take care of your toys. I tell my kids the same thing. The refrigeration systems are part of the brewery. They need all the attention that everything else gets. So, if we were going to walk up to somebody on the street and ask them what is refrigeration, the main answer we would probably get is it's a machine that makes things cold, right? Yes and no. Refrigeration, by definition, is the act of physically moving heat from one space, one object to another. Another thing that we should note here is that there is no hot and cold. There is only heat. So when we say we're moving heat, cold is defined as the absence of heat. Thermometers measure the amount of heat. All things have certain heat. Ice, a block of ice has heat. The Antarctic, you pick up a rock, that's got a certain amount of heat. So as refrigeration technicians, we kind of have to know how much heat is in something to be able to move it to a different space. So if we remove a certain amount of heat from something, that's when something feels cold. There's less heat in that object, so it feels cold. The easiest way that I came up with to describe how refrigeration works is like a sponge. If you had a bowl of water and you soaked up the sponge and you wrung it out in another bowl, basically that's how the gas inside the system works. And the gas inside the system absorbs the heat on the evaporator, which is the indoor portion of the system. That would be where you have your product that you're trying to keep cool. Soaks it up. You got the fans running in there. There's a whole lot of technical things that are happening as that goes on. So it's soaking it up. It gets pumped outside with the compressor. And the condenser, as you see there, that's a job we did out in the Finger Lakes, giant condensing units. And basically those fans reject the heat from the gas. That gas gets pumped back inside, and it's a cycle. So it keeps going over and over again. One misconception a lot of people have is that the gas runs out of their system. If you have a contractor that is telling you they need to constantly refill your system, they are taking you for a ride, because it is sealed. It is a sealed system. If they have to keep recharging your system, that's indicative of a leak. That's a problem. Should be taken care of, but under no circumstances should you schedule a regular recharge on your refrigeration systems. Basically, that's them being lazy. That's your contractor saying, I don't want to fix this. I'd rather get paid to put a Band-Aid on the problem. Okay. So we hear this quite a bit. If my beer is already 38 degrees, if it's sitting in the cooler, it's ready to go. Doesn't that mean my refrigeration should not be running? Well, it should run less, that's for sure, because there's less heat in that product already. But without getting overly technical, the second law of thermodynamics says that heat transfer occurs spontaneously from higher to lower temperatures, but never spontaneously in the opposite direction. Basically, heat travels from hot to cold. If you have a cold beer outside, the hot from outside is infiltrating the beer. The heat is infiltrating the beer, not vice versa. So the point here is that if heat wants to get into your cooler, heat will get into your cooler. Things like lights, doors, poor insulation, gaps and cracks, internal loads. When I say internal loads, that's if you have anything operating inside the space, including putting a keg of warm beer in there as an internal load. External loads would be if you had your boiler running right next to this and it's putting off a little bit of heat, or if your cooler was outside and it got a lot of sunlight or warm in the summer. So all that stuff comes into the cooler. We have to take that into consideration when we design your refrigeration. So when we're designing this brand new, we think of all these things. We say, where's it going to be? How long is it going to run? What are you putting into it? How is the cooler made? And it gives us a very, very good indication of what size refrigeration we got to put inside your cooler, basically. So that leads me to my next point, is purchasing used equipment. I sell used equipment. I'm not going to knock it. The problem with used equipment is a lot of times you don't know what you're getting. A lot of times it was designed for something else. It was designed for a convenience store. It wasn't designed for what we're using it for in the brewery. The other thing is a lot of times you're buying used refrigeration sight unseen. It's knocked down, it's on a pallet. You're buying it from somebody who knows somebody who has it. You wouldn't buy a used car without hearing the motor run. So be very mindful before you buy refrigeration without seeing the refrigeration run. You also want to talk to whoever is familiar with that system to make sure that it's hopefully going to do what you need it to do. You would hate to spend all that money on that used equipment only to have to call, that contractor or a different contractor out to troubleshoot it. We run into this all the time. And 9 times out of 10, it would have just been cheaper to do your research, do your homework the first time, instead of paying somebody to come out and fix it and or replace the equipment. Kind of brings me to my next point, and this is a very, I don't want to say sore subject with refrigeration guys, but coolbots are not okay, guys. They're just basically you're overriding any control that was supposed to go on that window air conditioner. Window air conditioner, I understand, cost you $150 at Home Depot. And if you burn one up, it's a whole lot cheaper than, trying to get another refrigeration system going. But listen, this is our livelihoods. I wouldn't bank my product on one of these. I've seen them work. I've seen them not work. If you go to Coolbot's website, they actually have a list of the downfalls of these systems. And if you were really reading it, 9 out of 10 of them apply to breweries. So what these are really made for is somebody who's got a farm stand, somebody who maybe a hunter, a fisherman that wants to keep an area cold for whatever they're storing. But when your livelihood depends on something, I wouldn't roll the dice on a Walmart air conditioner keeping my beer cold and my customers happy. Okay, so there are 5 main types of refrigeration, and there's thousands and thousands and thousands of different combinations and components that we can put together to make your system work properly and do different things and stand up to different rigors. But what we're going to talk about now is basically there's 5 types. I said 5 and I only listed 4. I just noticed that now. But so what we're really looking at in the brewery is mechanical. Mechanical basically says that there's a compressor in the system. The compressor is the pump that moves the gas from one end of the system to the other. There's refrigerant in the system. They're relatively safe. They're relatively easy to work on. They're relatively cheap. Okay, that's why they're prevalent in most restaurants, breweries. I mean, this is inside your air conditioner at home. This is inside your refrigerator at home. So this is the most common by far. You're going to have the most luck trying to find somebody that can work on this type of equipment. And for the most part, it's the safest. So moving on to absorption. Absorption is basically reserved for big industrial processes. Basically, there is a gas or a liquid in the system. Usually it's ammonia. And what propels that refrigeration through the system is a heat source. A lot of times it's an open flame, steam boiler, electric, anything like that, but there is no pump in the system. The smallest one that comes to mind for me would be a absorption refrigerator in an RV. And basically they use the propane from the RV with an open flame to heat that up. But this, it's pretty much excluded from most breweries that we're dealing with just because of a scale, a size thing. They're pretty expensive. They're hard to find somebody to work on. But mainly, they're very dangerous. The gas inside is ammonia. Ammonia displaces oxygen. So if there's ever a leak, basically you suffocate. If you find somebody that works on this, basically they work on it with a gas mask. And that's just, I mean, most places do not have this. We don't see a lot, but when we come across it, we generally refer it to another contractor. Evaporative cooling is it's reserved for cooler processes. Some things that don't require to be as cold, machinery that needs to be cooled down, that type of thing. Generally in our neck of the woods, you see it in factories with injection molding machines, that type of thing. So basically what you do here is there's water. The water is circulated. It gets hot with whatever process you're doing. It gets pumped back outside and basically runs over a bunch of plates outside. The heat goes to the atmosphere and that water comes back inside. The downside is that it only gets about 20 degrees cooler than what your outside temperature is. So if you're, in the summer, we might get into the 80s or 90s around here. Your indoor water temperature is only in the 70s, high 60s, in the 70s. So obviously we can't get down to 38-degree beer with that. So it generally doesn't affect us. We don't get into the brewery stuff with evaporative cooling. You might see it for a process here and there, but very, very little. Thermoelectric is probably the most obscure. Basically, it's using it's using electric currents to produce thermal properties. So it's used in control boards and spaceships and aircraft and that type of thing. But the most common people will never ever interact with something like this. So we will focus on mechanical. Again, that's the one that we're going to see everywhere in the brewery. So I'll talk about sizing things for a minute. Well, before I go too far, Jen, is there any questions that we got to look at or no?
Not yet. Does anybody have any questions? You can unmute yourself and ask if you do.
Okay, cool.
All right.
Well, like I said, if you do, I'm kind of running through these slides quick. So if you guys need me to slow down, talk about anything, just let me know. I'd be happy to help. Like I said, we do sell new equipment versus used equipment. And basically when I talk to a customer, the big selling point is just like buying a used car. If you're comfortable with putting a little bit of maintenance into a used car, saving some money up front, nursing it along the way, it's going to be just fine for you 99% of the time. A lot of people opt to get a new car, new equipment, just for the peace of mind, lower maintenance, prolonged life, that type of stuff. But what a lot of people don't consider is that used equipment was designed for something specific somewhere along the way. So like humidity. I'll touch on humidity because we see this quite a bit. We do a lot of our customers are agricultural customers, so they're storing open fruit, non-packaged stuff, potatoes, onions, carrots, corn. All that stuff has high humidity. If my system was originally designed to work in a convenience store, convenience stores systems are made to pull as much humidity out of the products as possible, because anything in a convenience store cooler is packaged, and we want to keep those packages nice and dry. We don't want to let the humidity infiltrate the cardboard. If you ever go to a convenience store and you pick up a 6-pack of beer and the bottles want to fall through the bottom of the box, that's a pretty good indication that their system is not doing what it was intended to do, because we really want to keep that cardboard dry. So any humidity that's in the space gets removed through the refrigeration cycle. So if that same system were used to store something like corn or lettuce, tomatoes, what you end up doing is you end up sucking the moisture out of that product, because it's not packaged anymore. It's open to the air. So you ended up with wilted lettuce. You ended up with corn that's dried out. So it's a big thing that a lot of people don't think about. We're in the brewery industry. We're fortunate that we don't really have to worry about our stuff getting dried out. Okay, but if you were, keep in mind when you're buying your equipment. In terms of capacity, I mean, the other thing we see a lot of times is somebody either builds a homemade box, which is fine, as long as you do it properly. When I say properly, it's usually people forget a vapor barrier. Forgetting a vapor barrier basically allows moisture into the room. But if you build your own room, or if you buy a used refrigeration box and the unit hanging in it is too small, you're not going to be happy. Okay, so we like to look at all those factors that I mentioned in a previous slide to make sure that the unit we put in there is going to do what it needs to do. If it's too big, it's not going to run long enough, and you're going to have a big swing in temperature inside the cooler. So it's best to really consult with somebody, somebody like myself, to know if your refrigeration is big enough. And like I said, doing it right the first time, you'll be grateful you did. That goes hand in hand with the next point, is efficiency. Last fact I saw, it was like the refrigeration in a brewery accounts for like 40% of the energy use. Okay, so if you have the right size equipment, you're going to save on your electric bill. If you have the wrong size equipment, too big or too small, you'll definitely see it. We get people all the time. It says, this new system that I bought from my cousin's uncle's brother who knows refrigeration, our electric bill doubled this month. Well, it's probably too small, and it's doing everything it can to keep your product cooled. You see that a lot. I mentioned the cool bots. They're going to run 24/7 in most cases. So efficiency goes hand in hand with capacity. And of course, they all come down to cost. Everybody wants to save money, but if you're doing it wrong, it's going to cost you more in the long run. Do it right the first time. get the used equipment. If cost savings are your primary concern, get the used equipment that's going to do it right for you. And the best way to do that is to consult with somebody. Now the other one is space. A lot of times people don't consider how much room a keg takes up, how much room a pallet takes up, how much room a pallet jack needs to turn around inside of a cooler. We get people that say, I need an 8x8 cooler. That's fantastic. Except an 8x8 cooler can only hold like 20 kegs, and most of us need more than 20 kegs in a cooler at any given time. So, all these things come into consideration. Those are things that should be on your mind if you're out shopping for new refrigeration. And I just pulled these pictures off of Google. So if I don't know if this is anybody's keg room here, but if it is, I apologize. But it's a pretty good picture of not having it sized for space properly. I don't know the application. I don't know if this is all they had to work with, but trying to move kegs in and out of here to me seems like a nightmare. That obviously you can't get a cart through there, and you'd have to manually move all those kegs up and down. So take those things into consideration when you're speccing out your equipment. So like I said in the beginning, take care of your toys. We've all seen this. What you're looking at there is basically dust, grease, oil. Whatever's in your air is going to stick to that coil because the coil's wet. So any dust that goes past that wet coil, this is, both indoor and outdoor coils look like this. So unless your coil looks like the picture on the right, you need to do something. You need to keep your coil clean, because anything that we're talking about today really, really requires that coil to be clean to do what it's meant to do in terms of humidity, in terms of efficiency, in terms of, all that stuff. So what I would recommend for everybody is maybe every 2 months. It's not very often. It's more in the summer than it is in the winter. You go outside and look at your outdoor stuff. A lot of times it's on the roof. It's sitting on a pad out back. If your coil does not look like that previous picture, the clean one, grab a brush and brush it top to bottom. Keep it clean. You get those the cottonwood pollen that flies around, that clogs up. 99% of the service calls we get in the spring are from cottonwood. You can brush those off yourself. Do not go left to right, go up and down, because if you bend over those coils, again, they can't move the air. So the first recommendation would be get a nice stiff bristle brush. Clean as much off as you can. If it's a little bit more substantial than that, I have a couple of cleaners up here that we use. The first one is a concentrate. Don't really recommend that for keeping it around your place. You're just not going to use it the way a contractor does. It's great stuff. It does the job great. We put it in a garden sprayer like this. You dilute it per the bottle, and make sure you wear your PPE, because this is nasty stuff. This is stuff that'll burn you. This is stuff that'll hurt your eyes. And basically saturate the coil and rinse it off. They do have non-rinse stuff. This is, you can buy this by the case at Grainger, and it's really good for breweries to keep on hand. And the good thing about this is you don't gotta drag a hose into your cooler to rinse it off. It does it on its own. Bringing a hose into the cooler isn't a terrible idea. You just got to make sure that you're prepared for what you're doing. Keep an eye on the drain. There's a drain that comes off the bottom of all the evaporator coils, and a lot of this stuff will accumulate in the drain, clog it up, and overflow it, and you'll have a mess. Keep an eye on that. But the main thing, if you're going to take on this maintenance yourself, and you're going to use a cleaner, you're going to use water, you're going to use a hose, turn the power off. We get a lot of service calls every year where people go to the well-intentioned, not on purpose, and what they end up doing is saturating a circuit board, saturating a motor, and then your repair is way more than just cleaning a coil. Now you're in for a motor or something else. So what we tell people to do is turn your power off. If there's any motors or boards that are going to be open to that water or cleaner, wrap them with a plastic bag, hit them with a little bit of duct tape. Doesn't have to be, super, sealed to the environment. Just keep the water off of it, and keep them on there until everything's dry. That's all we say. And again, wear the glasses, wear the gloves. You can breathe most of the stuff. It's not going to hurt your lungs, but basically follow the directions. One thing I do want to point out: don't use brewery chems. That's a bad idea. Brewery chems, they don't like aluminum and copper, and that's what all these refrigeration coils are made out of. So if you put brewery chem on there, it's going to clean the coil. It's also going to put a big hole in your coil. So do everybody a favor. They're the easiest chems that, as brewers, we all have on hand. Don't use them. Okay. A lot of times, if you don't have a dedicated brewery chemical, or excuse me, a refrigeration coil chemical, just kitchen degreaser works wonders too in a lot of cases. Okay. The very, I know I went through these slides really quick, Jen. So this was kind of towards the end of where I was going, but most of us have some sort of glycol refrigeration in the system. Glycol, basically pumping through the jackets on our tanks, keeping everything cold. It's very important that we know that glycol is going to keep doing what we need it to do. So the way we check it is with a refractometer, just like we would check our wort for specific gravity. But what this tells us is the freezing point of the glycol. And glycol degrades over time. You do lose a little bit of capacity in it. So it's good to check this once a year, make sure that it's still up to snuff. If you don't have your designed parameters for that glycol, just contact the refrigeration company that put it in originally, and they should be able to tell you if it was designed for -20, -30. And if it doesn't fall within those parameters once a year, then it's time to address it. But it's not something you want to find out after it's too late, because that's when you're trying to crash a tank and it doesn't, it's obviously on a Sunday afternoon or something like that, and nobody's out here to fix it. So just stay on top of those things. Glycol is relatively easy. There's two types of systems, and basically the way to check it is, so if there's a closed system, basically means there's pressure internally where the glycol is. Again, you're going to turn off the power. You're going to find the low system drain on that system, and you only need a drop. So once the power is off and you find that low drain, you get a drop on the lens of your refractometer. Check it out. If it's an open system, a lot of times there's a reservoir somewhere with a lid, and you might just be able to pull a sample out of that. But for the most part, this stuff, relatively maintenance free, but you just want to be on top of it, going forward. Basically, I know we're a little short here, but if anybody has any questions, I'd be glad to jump in and help.
Awesome. Thank you, John. Does anybody have any questions for him? You can go ahead and unmute yourself if you do. John, I know when you first got on, we were talking, and your company also does boiler maintenance as well. And
Yep.
I have a question for you. I worked at two breweries, separate breweries that I worked at. One did a continuous maintenance of like blowing out the boiler, and the other didn't do anything. And I'm curious, what like the one that started doing a regular maintenance had a massive issue of some of, I'm not quite sure what they're called, but some of the inserts, the round things in there leaking.
Mhm.
And I'm curious as if you could explain like what caused that, and what are some maintenance that we should be doing to keep our boilers efficient, and is it common practice to consistently blow out, or do we need to not do anything?
Sure. So I hate to keep bringing back the analogy of the car engine, but there's some people who don't do any maintenance on their car engines or their boilers, and the thing go forever. They're fortunate. It's a perfect storm of events where everybody's lucky and it runs forever. But there's also the people who are religious about their maintenance, and they still have issues. It's it's unfortunate. These things are mechanical. They're machines. They do break down. Um, you know, so in terms of the boiler that did break down that you're referring to, it could be a culmination of a few things. It could be the water at that location was high in minerals. Maybe it had a little bit of acidic compound to it. What happens when the water goes through the steam boiler? Obviously, you're flashing the water into steam, and all those minerals, all those chemicals in the water stay behind. So the heat exchanger inside the boiler really gets a lot of abuse. And if you don't blow your boiler down every time, some people blow it down once a week. If you keep it on all week and you're doing multiple batches, blowing down once a week is fine. And when I say blow down, basically what you're doing is you're turning the boiler off, you're draining it while it's hot. When you drain it while it's hot, you knock all those minerals in the heat exchanger back into solution. They go down the drain, and for the most part, the inside of your heat exchanger stays very clean. If you don't do that, it builds up. Think of soap scum. It builds up like mineral, deposits. A lot of those deposits eat metal. Once you, and again, talking about flashing the water into steam, you're driving the oxygen out of the water. Once you drive oxygen out of the water, it does become corrosive. So if you kept that water in there constantly without blowing it down, basically you're creating a perfect situation for that water to eat away the inside of the boiler. For bigger systems, for people who have basically the boilers running 24/7, I'm not going to limit to just those people, but a basically chemical treatment program for those boilers is smart too. There's contractors out there that just do that. We can refer you to people. Sorry about that. So basically, take care of your stuff. It doesn't matter if it's a boiler. It doesn't matter if it's a refrigeration system. If it moves, squeaks, or whines, you need to take care of it. And like I said, some people are just lucky that they don't maintain their stuff, and it runs for years and years and years. And other people are unfortunate on that. But when we operate the brewery, we blow down our we have a small steam boiler, and we blow it down every single time. So.
Awesome, thank you. And my other question for you, as I know you said with the refrigeration to scrub the coils, but
Yep.
is there any other maintenance that we should take away to maintain our refrigeration? And the same with the boiler, other than blowing down the system, is there anything else that we should be doing and putting in our practices to help maintain everything?
Generally, no. It comes down to keeping things clean. If a refrigeration system goes down and it's something electrical, it's generally not something you're gonna undertake yourself. If it's, if it's dirty, most people can clean a dirty coil, but I wouldn't expect somebody to get in there and start changing fan motors and circuit boards and that type of thing. That being said, if you keep it clean, generally the other things last a whole lot longer. On the boiler side, there's not a whole lot of maintenance to them if you treat them right. So, keep an eye on them. They start doing things that they normally don't do. That's when it's time for attention.
Awesome, thank you. Any questions for John? All right, well, I have just one last question for you, and I'm
Sure.
curious. Has your company ever installed glycol draft lines?
Oh yeah.
What is there any maintenance to that, and any advice to anybody looking to do that?
So a glycol draft line is basically, you're going to have a power pack unit sitting behind your cooler, keeps your beer lines cold for however long it has to travel across the brewery to your taps. So you have two systems there. You have there's a refrigeration system. There's a coil there that you have to keep clean, and usually it's behind your cooler. It's in the basement. It's in a crawl space or something. So it's out of sight, out of mind. It does have a coil. We've beat that horse to death. Keep that coil clean, because all of a sudden you'll get warm beer. 99% of the time, it's because that coil's plugged down in the basement and nobody's looked at it. On the glycol side, the physical liquid that runs alongside of your beer, again, that needs to be checked once a year to make sure that it's still viable and doing what it needs to do. In terms of, there's generally no filters on them. There's no there's no wear and tear parts that you need to worry about. So, again, keep these things clean.
Awesome, thank you. Any last comments? Steve, did you have one?
Yeah, I got a quick question. I'm certified, and I think it's a 602 and 603 certification that I had to get when I went through diesel school.
Mm-hmm.
When we did the refrigeration part of it, they were saying something along the lines, if you are a business owner, you can't service your own equipment. Is that true?
So you're getting into EPA guidelines now, and generally that is true, but what they're referring to is opening the system and actually dealing with the refrigerant gas inside. You can keep your systems clean. Nobody's going to haul you into court or give you a fine for that. What they don't want you to do is they don't want you to make a mistake unless you're trained. Or excuse me, I don't mean make a mistake, but if a mistake is made, the gas that's inside these systems is a greenhouse gas, so it's highly regulated. You shouldn't be able to buy a jug from Granger's or anything like that. So that's where we come into play. That is true. They shouldn't sell it to you. They shouldn't, give you the tools to access the gas inside the system. So there are pretty big fines for messing with EPA rules. So we abide by those fairly stringently. Yeah.
Okay, I am EPA certified, but I don't know what kind of refrigerant is in the newer systems. This was 14 years ago that I got the license.
So, I mean, even 5 years ago, there was half as many refrigerants as there are now. And the refrigerants are basically designed for different temperatures and different loads and different uses. So as the EPA comes out with different restrictions, we have different refrigerants almost every year. And then we get trained on that refrigerant. So it used to be where there was R12. R12 did everything. R12 and R22. If you had a jug of each, you could troubleshoot anything. And off the top of my head, I know my inventory, we keep about 12 different refrigerants in stock at any given time. So it really comes down to EPA and what they're mandating at any given time. So
All right, perfect. Thank you.
Awesome. Is there any other questions for John?
If anybody does have questions and you think about something later, my email is right on the screen. You guys can shoot me a technical question. You can, even just advice. We do a lot of help with breweries and planning and stuff like that, just to get some budgets under your belts. Let us know. We're here to help. Like I said, I'm in the brewing industry too. I have a passion for it, so I'm trying to further the knowledge in the industry. If you guys have anything, just let me know.
Awesome. Thank you, John. May not be the most glamorous part of owning and operating a brewery, but it's still just as important. So really appreciate you participating with us and sharing this knowledge. It's very useful. So thank you.
No problem.
And as he said, if anyone has any questions, go ahead and contact him. Again, thank you guys so much for joining the session. I hope to see you at the next one at 1 o'clock, serving food in your tap room. And have a great day. Thank you.
Thanks.
Thanks, John.